Let me just make this smaller. Okay, can you see? Alright, on the top, name each of the following chemical compounds. Make sure you use the right naming scheme. What that means is make sure that you check, is it ionic or is it covalent? And then you're going to name it accordingly. And then how many atoms of each element are present. Okay? So the top is a little bit easier. What's the name of this CaF2? Calcium what? Fluoride. Does it need a Roman numeral? Why not? Only one. Okay. So, how many calciums do you have? One. How many fluorines do you have? Two. Bonus. Alright, the next one. BeOH2. Beryllium. What was it? Hydroxide. Does it need a Roman numeral? No. How many berylliums?
One.
How many oxygens?
Two.
And how many hydrogens?
Two.
Okay. NO2. Nitrogen dioxide. Why are we using the prefix di? It's covalent. Good. So nitrogen dioxide. Right? How many nitrogens? How many oxygens? Two. You're going to need this for the next step. That's why we're spending some time on it. Alright, Al2SO43. Aluminum. Look at you on fire today. Aluminum what?
Sulfate.
Perfect. Sulfate. Okay, aluminums. We have how many? Two. Sulfur we have 3. Oxygen we have 12. Does everybody understand where those numbers came from? Okay. What's this? NH4NO3. Angeli is on fire this morning. Ammonium nitrate. Okay, good. Let's count N's. How many N's do we have?
4.
Not 4.
Oh.
2. Okay, there's one here, and there's one here.
Yeah, now
That's why we're practicing. That's why we're practicing. All right, H, 4, and O, 3. All right, S2F2. Disulfur. Difluoride. This is covalent, so we need the prefixes. Okay, so we've got disulfur, difluoride. This one's easy. 2 S's and 2 F's. All right, Na2CO3. Lexi, what do you think? Sodium. Yeah, carbonate. Good. Okay, not dicarbonate, just carbonate. Sodium, carbonate. How many sodiums are in there? 2. How many carbons? How many oxygen? 3. All right, last one. CH4. What? It is methane. I'm going to write that down here because that's the common name. What would it be? I thought she went to the bathroom and she comes back with a fancy drink.
it was a quick trip.
It was a quick trip. How did it get here? Oh, okay. Your friend brought it. There's cookies in there? Oh, all right. Back. Focus. All right. Focus. Got distracted by fancy drink. All right. CH4, common name methane. Yep. Okay. But if we're going to name it according to the IUPAC rules, we would say carbon tetrahydride. It's the same thing. It doesn't matter. Okay, both of them are correct. Okay, methane or carbon tetrahydride. Go ahead. Either one. Either one is fine. Okay? All right, now, how many carbons? Uno. How many hydrogens? 4. Okay. Now we got a problem. Okay, these are a little bit tougher. We have to write the formulas, and if you can't write the formulas correctly, you can't get this. See, up here, it was nice and easy because they gave us the formula. But here, they gave us the name, and now we have to figure out how many of these suckers we have. Okay, this one's not bad. Phosphorus trichloride. Did it get quiet in here? Phosphorus is P. That's 1. And 3 chlorines. This one was nice and easy. They tried to trick us and thought it was going to be hard. All right, magnesium hydroxide. Magnesium? Nope. Okay. Magnesium is Mg. Hydroxide looks like what? OH. Now, this is what you can't forget. You have to put the charges in, and you have to cross them down. If you don't do that, you'll have a problemo. Okay, so we've got Mg. There's going to be one of them. Oxygen, there's going to be 2, and hydrogen, there's going to be 2. Potassium. What's the symbol for potassium? K. Allison's on fire. All right, K. What's phosphate? PO4 minus 3. You getting them over there on my shoulder?
I am.
Okay, good. So we've got plus 1, and we got minus 3. So this 3 is going to come down here. The 1's going to go down here, so we don't have to move that. And now we have the correct formula. So we've got 3 Ks, 1 P, 4 oxygens. Woohoo! I know. Diphosphorus tetrabromide. 2 phosphorus. Okay, so these are actually easier than the other ones, aren't they? When they're covalent, it's easier because they tell you how many they have. So phosphorus, you've got 2, and bromine, you've got 4. No, this is ammonia. Mr. Drucker never does bad field trips.
No, they'll be outside in the cold.
Wait, is it carbon, hydrogen, 3? Oh, no.
Ammonia. Ammonia. They're struggling over there. What about this side of the room? Mia, you have a number for me? Ammonia? NH. It's ammonium. You're right. You're right. Ammonia, not ammonium. NH3. Good. With a little help from our friends, we'll get it. Okay? This is yes. Look. This is yes. This is no. Okay? Yes. No. Alright, so ammonia, NH3. Ammonium would be NH4 plus. Alright, no, ammonia has 3 N's and, what? 1 N and 3 H's. I got ahead of myself. Germanium is GE. Okay, you got to look that up. What?
GE has a charge of 2.
GE has a charge of +2.
Yes.
Okay, so hold on a second. Let's take one step at a time. So germanium is a +2. Phosphate is a PO4 with a -3, right? Cross them down. 3, 2. Put that sucker in parentheses. Okay? Now we can write how many we have of each. We have 3 germaniums, we've got 2 phosphorus, and we've got 8 oxygen. Okay, ammonium sulfate. Here's your ammonium now, Mia. Ah, good girl. All right, NH4, and it's a +1 charge. Sulfate is SO4 with a -2 charge. Good job. Okay? You see it? All right, how many N's? 2. How many H's? 8. 4. Okay. Diphosphorus is 2 P's. Pent is how many? 5. Oxide, O, 5 oxygens. So you got 2 P's and 5 O's. Look at us go! Okay? And yesterday we also talked about moles, right?
Yeah.
Mole is a group. How many are in that group?
6.23.
Right, 6.02 times 10 to the 23rd. So if I write H2O, how many groups of H2O do I have? 1. So I have 1 mole of H2O. If I break that down into its pieces, how many groups of H do I have? I have 2 moles of H and 1 mole of O, if I broke it into its pieces. But here it's all connected, so it's going to stay connected. I'm just getting I like drawing on this one because then I have record of what happens here. There we go. Give me my pen. So if I have 1 mole, ooh, it's big, 1 mole of, I don't know, calcium phosphate. Okay, first question. How many moles of calcium phosphate do I have? 1. I have 1 mole of calcium phosphate. How many moles of calcium do I have? 3. How many moles of phosphorus do I have? 2. How many moles of oxygen do I have? 8. Okay? That's it. You're good. You're good. Okay. You see the 8?
Yeah.
Okay. I think we're ready to move on. You good? Okay. Yeah, I think I am going to teach you one new thing today. And then I'm going to give you some practice. Okay? All right, let's take a nice easy one. Let's take H2O again, because I love H2O. Okay? Dihydrogen monoxide. If I asked you to bring me a dozen cookies, because I'm really hungry, I want a dozen cookies. Okay? How much would that weigh? Chocolate chip cookies. Oreos.
Oreos? I think like
Okay, half a pound, right? So if I asked you to bring me a dozen Oreos, it would weigh about a half a pound. Let's just say. What about if I asked you to bring me a dozen elephants? How much would that weigh? A lot more. Okay. 24,000? Okay. So If I asked you to bring me a dozen cookies and I asked you to bring me a dozen elephants, I'm still bringing the same number of things, correct? 12 cookies or 12 elephants. But they don't weigh the same amount. I'll take the cookies. Is that what you said?
I said the elephants ate the cookies.
Oh, the elephants ate the cookies. I thought you said, I'll take the cookies. All right. So, if I asked you to bring me a mole of water, it is a lot of water. Well, it's not really a lot of water because they're really, really small, remember? Well, we're going to find out how much it is in a second. And I asked you to bring me a mole of lead acetate. Lead acetate. Okay. Which are they going to be the same size when you bring them to me? Even though you're bringing me the same amount. No. Okay. There's more elements, and these elements are, lead is a really heavy element. Okay? Just like the elephants didn't weigh the same as the cookies, these guys don't weigh the same. Okay? When we are looking to measure a mole of something, so this is 1 mole of water. We all agree that this is 1 mole of water. Okay? I want to know how much 1 mole of water weighs. You have your periodic tables in front of you? It's not that hard. You can do this. Okay? Can we agree that there are 2 hydrogens and there's 1 oxygen in that water? In the water. In 1 mole of water, you've got 2 hydrogens and 1 oxygen. You agree? Okay. I want you to look at hydrogen on the periodic table. It's in the upper left-hand corner. Okay? You see the mass of hydrogen?
1.00794.
Okay, can we make our life easy and just say 1? Okay, good. All right, it weighs 1 gram per mole. So this 2 times 1 gram per mole equals 2 grams. And oxygen is going to weigh how much?
16.
Yeah, let's round them to whole numbers. It makes our life a lot easier. And this weighs 16 grams. So if this weighs 2, 1 for each hydrogen, and 16, then the water weighs 18 grams per mole. Okay? So if I wanted to bring somebody 1 mole of water, I would measure out 18 grams, and that would be 1 mole. What about the lead acetate? Would the lead acetate weigh 18 grams? Probably not. So let's figure out how much it would weigh. So lead, how many of them are there? 1. And it weighs 207. Okay, so that's 207. Carbon, there's 2 of them. They weigh 12. That's going to be 24. Hydrogen, there's 3 of them. They weigh 1. That's 3. And oxygen, there's 2 of them, and they weigh 16 apiece. That's going to be 32. Okay, so how much does this lead acetate weigh if I gave you 1 mole? 1 group. If I handed you 1 group, how much would it weigh? A lot. Yeah, get out your fancy math makers. How much?
266. Credits to Allison.
Credits to Allison? Make sure she's right.
Yeah, she's right.
Okay. 266 grams per mole. So these are like my cookies, right? They're smaller. These are like my elephants. They're bigger. Moles of something, groups of something, don't need to weigh the same. They just need to be the same number of things. Understand? A dozen eggs, a dozen cookies, a dozen jelly beans, a dozen mice, a dozen potatoes, a dozen whatever. They don't weigh the same, but they all have 12 things in them. A mole of something, they don't weigh the same, but they all have the same number of atoms within them. Eva, you got that? Take a sip of that drink. You're falling asleep.
I just did.
Okay, good. Just want to make sure you're awake. Right, you good? Okay. Jacob, you good? Okay. What? What happened? I'm going to give you another one. Actually, we can do these. On the paper I just gave you, we had calcium fluoride, CaF2. What does 1 mole of calcium fluoride weigh?
40 grams.
No.
Where is that?
Well, the calcium, there's one of them. And there's just one, right? We counted that already. And calcium weighs 40. Okay. But the calcium fluoride, how much does it weigh? Fluorine, there's 2 of them. And they're 19 apiece, which is going to be 38, right? 19 and 19 is 38. 40. So 78 grams per mole. Okay. BeOH2. BeOH2. Beryllium, we decided there was 1 of them. Oxygen, there's 2 of them. Hydrogen, there's 2 of them. How much does beryllium weigh? 9. Oxygen weighs 16, and hydrogen weighs 1. 9, 32, and 2. So 9, 10, 11, 12, 13, 43. That's not right. Is that right? Yeah, that's right. This number that we're calculating right now is very important. We're going to be using it a lot. Okay? So you have to know how to make, need to know how to find how many grams are in 1 mole of a specific substance. Okay? So they have to give you a substance and they'll say how many grams are in 1 mole. This is called gram formula mass. Okay? It's the mass of the formula in grams. Just read it backwards. It's the mass of the said formula, whatever that formula is, in grams. And it will give you grams per mole. You can write it here or you can write it like this. Grams per mole. Oh, I didn't tell you this. MOL is short for mole. MOLE. Is that what you were going to ask me? Okay. Why they took 1 letter off and said that's the abbreviation for it? I don't know, but they did. Okay? It's not G per M, because M would be meter. So it's grams per mole. Diego, did you have a question?
Is it going to be short answer on the reason?
No. A short answer. Yeah. Yeah. But this is only the beginning. They're not going to... There might be one question that says, what's the gram formula mass of? But then we're going to use the gram formula mass to do other calculations. Yeah. So we have to know how to get the gram formula mass. Because the gram formula mass... This is what the gram formula mass allows you to do. It allows you to translate between moles and grams. And between grams and moles. So if they give you moles, you can find grams. If they give you grams, you can find moles. Everything we do, calculation-wise in chemistry, is done in moles. But they're going to give it to you in grams. So you'll have grams, you'll translate it to moles, you'll do your chemistry magic, and then you'll turn it back into grams. That's how it'll work. Okay? Because we are working with atoms, and we need to always work in moles of those atoms, in groups of those atoms. You understand? Okay. I'm going to give you some practice to work on. Let me shut this thing off.